Hi, I'm Andreas Ladisch. I'm the coordinator of i14y Lab, which is a publicly funded project dealing with the development of Open RAN and Open RAN testing. So one important factor of Open RAN testing is energy efficiency and how energy efficient different components are. So it's very important to develop a comparable solution and comparable test results concerning energy efficiency. Otherwise, you cannot say which solution is better than the other. Okay, when we start the activity concerning energy efficiency of Open RAN, more or less nothing was existing. So because Open RAN was a quite new topic, and all the activities related to energy efficiency testing just talked about bulk RAN solutions, so disclosed solutions that we usually have applied in the network so far. So we started from zero and developed a framework how to measure the energy efficiency. That means we broke it down to the different components of Open RAN, like I/O, CO, DO, and that includes virtual network functions and the related hardware. And more important, it's also the higher layer where so-called RAPs coordinate different base stations and different radios to improve the overall efficiency of an entire subnetwork, a metro network also. Honestly, nothing was existing for that, and we developed from scratch together with our partners all those solutions.
Okay, so I'm Olaf Bonnes, working for the i14y Lab in the infrastructure part mainly, and I'm responsible that we have all the infrastructure set up and operating what we need for our, let's say, 5G investigations, for our lab setup and the work with our project partners. Besides the testing and the Plugfest we are hosting permanently, we are also doing a couple of basic, let's say, academic investigations inside our lab setup. And one of the major topics which is of interest for us is, for instance, the energy consumption and energy efficiency of our components of an Open RAN architecture. Especially in that direction, we are investigating how, for instance, a virtualized network function, like a virtualized containerized ODU or OCU, how that is working and which energy is consumed by such a setup. In that direction, we have integrated let's say, automated measurement framework where we are able to investigate the different load consumption and energy efficiency of Kubernetes-based SRS, ODU, and OCU implementation, which we are hosting here on one of our servers, and where we measure based on the Kepler measurement tool which energy these virtualized components need under different load situations. The framework of this whole approach is mainly based on a white paper the colleagues from Rimedo created together with us, with i14y Lab partners, and which has been already propagated in LinkedIn and is also used in other projects within i14y Lab. And together with the Rimedo colleagues, we will extend our setup in order to also investigate, let's say, the implementation of SMO-based RAPs in order to optimize different, let's say, network situations and how this then infects the energy consumption of the virtualized network functions.
I'm sure, and what I see already is that vendors will adapt to our framework and also that operators will use it. Let me share one example. So the latest news from the last Open RAN Alliance meeting in Seattle, there was a broad discussion dealing with the question how to do energy efficiency testing and how to make it comparable. And we have seen a lot of different OTICs, that are the Open Test and Integration Centers. Different OTICs have developed different contributions and add-ons to our basic framework, I would say. So I would say it's a broad adaptation of the ecosystem.
Hello, my name is Marcin Dryański and I'm the CEO and co-founder of Rimedo Labs. We are one of the i14y Lab consortium associated members, focusing on providing expertise in energy efficiency, security, conflict mitigation, and xApps Arab development. We want to introduce you to the current work we are doing with i14y Lab and Deutsche Telekom. That work is a part of a bigger topic on unified energy efficiency testing framework. Recently, we moved from the conceptual considerations to conducting actual measurements in a lab setup, and in this video, we present the validation of VNF power consumption in an ORAN setup. Let's start with the main goal of this project part. Here we aim to establish the energy measurement methods for virtualized Open RAN, focusing on the rig space and operational reality of measuring it. ORAN and rig promise energy increased efficiency. The key questions we put in this context are: how to measure energy efficiency in an ORAN environment? What tools should be used for such measurements? How much power does each component consume in a virtualized environment? What's the power consumption of software and hardware components? And based on those, the following detailed goals were posed for this project phase. Measurement of power consumption of VNFs at various levels: server, CPU, pod or container. Utilization of tools dedicated to each level, including electric socket, redfish and Kepler tools. Measurements of the specific ORAN components like ARAP or rig. Diving into the relation between the RAN event and power consumption. Now, let's set up a scene for achieving those goals. If you remember from our previous work and video, in the conceptual framework project part, we created 4 different views approaches to energy efficiency testing. The first one, the component level shown on the left upper corner, aims to individually test various software and hardware components and to measure or validate their energy consumption, energy efficiency in a small setup. In contrast, the global feature-based testing shown on the upper right corner aims to test the xApps Arab for energy saving in an emulated environment, testing their performance in a large-scale networks. The deployment option that is shown on the lower left corner focuses on putting the actual ORAN stack components in different points of presence to add realistic deployment aspects like latencies and distributed processing. Finally, the lower right corner multi-link testing broadens the scope of all the previous ones, aims to validate the energy consumption or energy efficiency in a close to real network setup. Moving now to the current considerations, we selected the component level option. The actual setup in this project is deployed in i14y Lab on the servers as software components for the ORAN stack, including RAN, rig and the ARAP. The testing aims to validate the power consumption of both the whole setup and the individual VNFs, as well as lower level components. In the next part, my colleague Marcin Hoffman will guide you through the details of the setup and the conducted measurements.
My name is Marcin Hoffman, and I'm a Technical Solution Manager with Rimedo Labs. I will walk you through the test environment and results we obtained regarding the power consumption of VNFs in Open RAN. Let's start with an overview of the test environment with the hardware setup. This is summarized in the table on the left. The key part is a Dell R750 enterprise-grade server. It is running redfish telemetry, enabling measurement of power consumption related to its hardware subcomponents like CPU or memory. Apart from that, it is hosting Kepler, which provides insights into the power consumption of individual ORAN VNFs such as rig, xApps or ARAPs. The Dell R750 is attached to the GUDE electric socket, providing ground truth of overall server power consumption. The Dell R750, which is subject to the power consumption measurements, is hosting 3 software components. First is the xApps Lab, being a lightweight non-real-time rig developed by Rimedo Labs, which is hosting cell on-off switching xApps and providing O1 termination for communication with RAN emulated by Keysight rig test, visible in the bottom left corner. Note that rig test is residing on a separate server, not contributing to the power consumption of Dell R750. The xApps Lab is built of multiple VNFs, which will be subject to evaluation of their contribution to the overall power consumption. The second component is Energy Efficiency Testing Framework, visible in the center, being responsible for collecting the power consumption metrics at the level of hardware components using redfish and split into the individual VNFs using Kepler. It is also exposing measurement data through Prometheus to the third component, visualization with Grafana visible on the right. The resultant Grafana dashboards would be described in the latter part of the video. To assess the power consumption of xApps Lab lightweight rig and cell on-off switching xApps running on a Dell R750 machine under controlled test condition, we need to feed it with the run data. For this purpose, in our test environment we use Keysight rig test. The utilized network setup in the figure on the left has 12 cells in total, 3 coverage and 9 small cells, providing service to 12 groups of 10 users. To create an opportunity for cell on-off switching xApps for power savings, we follow the varying network traffic depicted on the right. In other words, by having a traffic load varying in time, we can trigger cell on-off switching xApps decisions that potentially affect the power consumption. Most importantly, the Keysight rig test provides full compliance with the ORAN-O1 interface, supporting both PM data and configuration management. In the latter part of this video, we will demonstrate how the processing of them affects power consumption. After getting familiar with the test environment, let's discuss the measurements themselves. For reliable evaluation of the power consumption of Open RAN VNFs, we followed a three-tiered approach. First, we use direct power measurements from the electric socket to have a ground truth, which can be used to calibrate Redfish. Second, we go beyond a single value of the total server power consumption. By using properly calibrated Redfish telemetry, we can evaluate the power consumption of individual hardware components of the server, like power supply loss, memory, or fan power. Finally, on the third tier we use Kepler to dive into the power consumption of CPU, additionally split into individual software components like processes, pods, or containers. Now let's move to the video demonstration of power consumption measurements using Redfish and Kepler running on the top of the introduced test environment. Here is a Grafana dashboard with Redfish telemetry measurements of Dell R750 running xApps Lab, which consumes O1 data from Keysight rig test deployed on an external machine. Redfish telemetry enables us to gain insights into the hardware subcomponents covering system power consumption, total CPU power, total fan power, total memory power, total storage power, supply loss, and remaining power. We can also see the contribution of these components to the overall power consumption. Note that the fan and CPU consume the most. The next Grafana dashboard visible here is related to Kepler measurements captured in parallel to Redfish telemetry. The key feature of Kepler from the perspective of energy efficiency testing in a virtualized ORAN environment is its capability of tracking the power consumption of individual VNFs. In the video example, these are VNF components of xApps Lab, namely RAN-O1 notification component, network configuration component, performance management component, cell on-off switching xApps component, influx database component, Redis database component. This allows mobile network operators to track which VNFs consume the most power to identify fields for optimization, as well as compare between vendors of ORAN VNFs like RIG or xApps from the perspective of building the most energy-efficient component stack. While continuing on this thread, let's now demonstrate how we can use the proposed measurement tools and Keysight rig test emulating O1 traffic to find a relation between run event and power consumption. On the left we can see a Kepler dashboard, while on the right logs of performance management and cell on-off switching xApps VNFs. Now we can see incoming PM data, which is related to power consumption spikes visible in the Kepler dashboard. In this case, power consumption spikes on the CPU side are only about 3 watts, but keep in mind that we have only 12 cells in total. While using the presented test environment together with Redfish and Kepler, we can increase the number of cells in a controlled way and provide an estimation of how much energy VNFs would consume in a production-grade scale of hundreds or thousands of cells. The demonstration showed how we can narrow down the scope of power consumption measurements. We started from the Redfish telemetry, providing overall system power consumption, additionally split into its hardware components, with fan and CPU being the most power-hungry parts. But this is not enough to get a clear overview of power consumption related to the virtualized ORAN software components. Thus, we utilize Kepler to get detailed insights into how much power individual ORAN VNFs consume, and how this correlates with what is happening in RAN.
Thanks, Marcin. Let me now summarize the value of the presented methodology for the wider ecosystem. The granular visibility into VNF power consumption allows for evaluation of the contribution of individual components to the overall power consumption. It enables extrapolation of the power consumption for larger network setup through scaling approximation. It can be used to identify most energy-hungry software components. And finally, it allows for correlation of the power consumption of certain VNFs directly with the run events like PM collection or RAP control execution. The key takeaways for the vendors and operators from these validation tests are that they can validate the power consumption of AI/ML-based run applications, compare the power consumption of VNFs running on different hardware setups, and estimate power consumption and power saving in the context of a larger network. Thanks for watching, and we encourage you to reach out to i14y Lab team or us for more information and materials.